All right, so the practice quiz here. Now, 1 and 2, we have mid-segments. Those two are equal. Those two parts are equal. So these are midpoints. Makes that mid-segment. What that means is this is half of FD. So if I want to catch it back up, I'm going to multiply it by 2. You got to use parentheses to make sure you multiply everything by the 2 with distribution. And that will catch it up to the whole FD there. So now we'll distribute. We want our x's on one side, so I'll minus x. Add the 32. Divide 12. And all this says is solve for x. We got it. We're done. Now 2, same question. Double this one. Well, it's not a binomial, so that's even easier. It's just 2x. Now we want all our x's on one side, and usually we avoid negatives, but here I'm going to move the x over to the left. That way all our x's are on one side, all our numbers are on the other. So all I have left to do is just divide. All right. Now 3, same question mostly. It's just this time it says find BC. Well, it's the same idea. We got to double this one. Catch it back up to the bottom. Distribute that 2x minus 6. Now we'll minus the x. Add the 6. 11. We've done like the hard part. Now we just have to solve for BC. So we plug that 11 in to x minus 3. So 11 minus 3 is 8. There. So again, these are the same kind of questions. It's just you got to plug your answer for x back in to get the overall answer. So on 4, double the smaller one. Distribute, we get 4x plus 44. I'm going to subtract 2x. Then we'll subtract that 44. So that is negative 18. Divide by 2. Now we've done all the hard part. Just don't forget to plug it back into this expression for x. 2 times negative 9 is negative 18 plus 22 is 4. So that's your overall answer. So those were mid-segments. Now on number 5, we have the whole hypotenuse and nothing for the altitude. So this is the hypotenuse rule. Sometimes it's called the leg rule. So it's a hypotenuse over the leg, and then the leg again over the projection. Now that projection is just that chunk of the hypotenuse that goes with the leg. Cross multiply. Divide 100. Now this time, we have the altitude. So we just pick one of the parts of the hypotenuse. So you just pick one, I don't know, 36, over the altitude. And then the altitude again over the other part. Cross multiply. And 48 times 48, 2304. Divide that by the 36, 64. Number 7. Oh, back to the whole hypotenuse rule here. So the hypotenuse over the leg, and then the leg over the projection. Cross multiply again, and then divide by your 9. 25. Oh, back to the altitude rule here. So you pick one of the pieces of the hypotenuse. I don't know, maybe I'll do the x first this time, or the altitude, and then the altitude over the other part of the hypotenuse. Cross multiply again. 12 times 12 is 144. Then you divide by that 9, or 16. And I accidentally let one that's identical, 60, 36, and x, 60, 36, and x. I let that slip through. So it's just the same as this one. Now, it's been a while since we've done this. State if the 3 numbers can be the measures of the sides of a triangle. Now, I'm going to do these out of order to remind you how this works. On 11, we take a look. Oops, let's call this side the 24. Then we have a 9 and a 12. Now, I didn't draw those connected because, watch, 9 plus 12 is only 21. If 9 plus 12 is only 21, but this bottom is 24, these could never connect. They wouldn't be as long as the 24. So that can't be a triangle. In order for it to be a triangle, possibly, you got to be able to add the smallest 2 up and have it bigger than the third one. If it just equals it, then it would be exactly on the same line, and that wouldn't work either. So it's got to be bigger than the biggest one. So here are the 2 smallest. 9 plus 6 is 15. That's bigger than the 11, so yes. Now on 12, we got similar triangles, so we're going to set up a proportion and cross multiply again. But the way this is kind of spun around, let's go to the letters. We got HG. That's the first 2. So that corresponds to the first 2 LM. Now, since I started up here for the top of the first fraction, I got to start up here for the top of the second, 9x plus 9. And that's HF, the first and the third. I mean, we only have one choice here, but just to verify it, first and the third, 63. Now it's kind of a bad example anyway, because these are both 63s, but it is what it is. So we cross multiply. 54 times 63. And then we'll end up having to distribute 63 times 9 is 567. So we're going to subtract the 567 here. And then divide by the other 567. 5. It only says solve for x, so we're done. Now on 13, pick one of these. I don't know, pick the 11. 11 is S and R, which are the first 2. So that corresponds to UV down here. And then we got ST, which is the second 2. I mean, we only have one choice, but VW is indeed correct. Cross multiply. Distribute. So now we'll minus the 99. And then divide by the 198. 6. There we go. All right. Now in class, we talked about line dilation centered at the origin. When something is dilated, when you're dealing with similarity, everything is increased in proportion. Distances and points change, but angles or like tilt, like the slope, that stays the same, but then multiply your y-intercept by 3. And now 15, dilation of 2 about the origin. When it's centered on the origin, which most of them are, all you got to do is multiply the coordinates by the scale factor. But let's get the coordinates. -1, 2, 1, 2, and D is 1, -2. Multiply all those by 2. C prime 2, 4, D prime 2, -4. So let's see. Left 2 up 4, B prime. Right 2 up 4, C prime. Right 2 down 4, D prime. Then you got your triangle. All right.